Alright, so I'm going to do the review now for section 2.7. Realistically, the best thing you could have done is completed the entire review by yourself before you actually sat down to watch this video. It would be much, much better in terms of studying for the test if you did this, like I said, without watching the video. And then as you're watching the video, you should be checking your work rather than having to write everything down. That being said, if you're just watching it and copying it, it's better than doing nothing. So let me see what I could do here. So question 1 wants me to find the domain. I did a few of these throughout the chapter. And anytime I'm asked to find a domain of a fraction, I always have to ignore the numerator. If you do anything with the x plus 2, you're going to get a number that doesn't belong in the answer. For all domain questions of fractions, I'm going to set the denominator equal to 0, and that's going to give me a number that goes in my answer when I solve that, but it's not going to give me the whole answer. So I ignored the x plus 2, I solved the denominator equal to 0, and now I'm going to write my answer. And I was asked to write the domain in a sentence, so I'll do that. I'll do exactly what my instructions ask for. So I'm going to say the domain, and then I could just say is, or I could say the domain of x plus 2 over x minus 4 is all real numbers except 4. So this is specifically what's asked for. It would be okay if you made a number line that had negative and positive infinity, put 4 on the number line, and created intervals, and wrote your answer in interval notation. Even though it doesn't ask you to write the domain in interval notation, it's completely okay to do that. It's just that most students generally do better with the words. But either one of these would be acceptable answers for the domain answer in part A. I can tell this number is a correct number if I plug it into the original problem and get undefined. If I take the number 4, which is the number I threw into my domain answer, and put it into the original problem, I get 6 over 0, and any fraction with a 0 in the denominator is undefined. So I know that 4 wasn't a good number to plug into the domain. Similarly, I know that negative 2 is not a good number to plug in the domain. Negative 2 is what you'd get if you set that equal to 0, because if you plug negative 2 in for the x, you don't get undefined. If I plugged 4 in for x, if I did it on my calculator, if I did 4 plus 2 over 4 minus 4, my calculator tells me it's a math error because this is undefined. On the other hand, if I took the negative 2, which is what you get if you take the numerator equal to 0, and you plugged it in, and you did negative 2 plus 2 over negative 2 minus 4, you'd get 0, and 0 is not undefined. The only numbers that need to go in my answer, the sentence form of my answer, are numbers that I can plug in for x and get undefined. So negative 2 would be an incorrect number to plug in my answer because when I plug it in, I don't get undefined. 4 is a correct number to plug in for x because when I plug 4 in for the x's, I get undefined. So that's number 1, part A. I'll move to part B. Part B is more or less the same problem. I'm asked to find the domain of a fraction. And again, anytime I'm asked to find the domain of a fraction, I know I have to ignore the numerator. If I do anything by setting the numerator equal to 0, I'm likely to get a number that doesn't belong in my answer. What I need to solve algebraically is where the denominator is equal to 0. And because that has a square, I know I'm going to solve by factoring. I don't need bottoms-up factoring because the b squared doesn't have a number in front of it. I know the signs are going to be plus and minus, so I could maybe have a +1 or a -63 or a plus 63 and a minus 1, or a plus 9 and a minus 7, or a plus 7 and a minus 9. I don't do real well with 63. There's more numbers that multiply out to be 63, but I already have the pair that I need. I need the pair that give me the negative 2, and that's a plus 7 and a minus 9, because 7 minus 9 is negative 2. So in my parentheses, I'm going to put a plus 7 and a minus 9. So I have my signs right, factored properly. Now I'm going to take those parentheses, and set each one separately equal to 0. When I set the b plus 7 equal to 0, I'm not done. I'm going to minus 7 from both sides and get b equal to negative 7. When I take the b minus 9 and set it equal to 0, I'm going to add 9 to both sides and get b equal to 9. Those are the numbers that belong in my answer. Because the instructions ask me to write my domain in words, I'll write my domain in words. So I'm going to say the domain. I'll do a little bit lazier answer. I'll skip the of the problem part is. So I skipped the of the part and just went to the domain is all real numbers except negative 7 and positive 9. So this would be the perfect answer. And if you just really liked interval notation, it's not asked for, but I'll accept it. To get an interval notation answer for this domain, you create a number line with negative and positive infinity on the edges, and the numbers negative 7 and 9 placed in correct order. In interval notation, the domain would be the interval from negative infinity to negative 7, union the interval from negative 7 to 9, union the interval from 9 to infinity. Like I said, I probably wouldn't expect that answer, but it's okay. I should make sure that both these numbers, negative 7 and positive 9, are correct numbers to have in my answer. To do that, I'll plug negative 7 in for the b. I'll go negative 7 squared minus 4 over negative 7 squared minus 2 times negative 7 minus 63. Don't want to do that by hand, so on my calculator, it better give me some sort of error message when I do this. So I'm going to go negative 7 squared, has to be in a parentheses, minus 4 over negative 7 squared minus 2 times negative 7 minus 63. If I get that error message, then it's a good number to plug it in my answer. And I just did. So I got a math error, which means this is undefined. So negative 7 is okay to have in my answer. I'll do the same thing with 9. With 9, I really don't need the parentheses because when I square it, because it's not a negative number. It wouldn't be wrong to have the 9 in a parentheses, but it's just not necessary. Same deal. I don't care to do this by hand. So I'm going to break my calculator out, and hopefully I get the same math error, because that's what it means. That's how my calculator says something is undefined. And that's specifically the numbers I need. I need the numbers that I plug in and get undefined, and I got the same math error. So I feel good about the numbers. If you put any other numbers other than negative 7 and 9 in your answer, and you did this computation, you wouldn't get a math error. You'd get some number. You may get 0, but 0 is different than undefined, and it wouldn't be a correct number. So I've checked it kind of the best I could, and I'm done with that problem. Again, the problem only asks for the domain in words, but if you give me interval notation, I'm completely content with that. Next thing I want to do is reduce this fraction, and reducing is easy. To reduce this fraction, there's no factoring, and the nice thing about it is there isn't any adding or subtracting, and these are the kinds of problems that are easiest to reduce. So I'm going to rewrite this problem without its exponents. Writing 4 a's and 3 b's in the numerator, 1 a and 5 b in the denominator. First thing I need to do is reduce the fraction 24 over 21. And if I can't do that in my head, I can bust it on this calculator, do 24 over 21. 24 over 21 reduces to 8 over 7. So in my answer, there's going to be an 8 in the numerator and a 7 in the denominator, because 24 divided by 3 is 8, 21 divided by 3 is 7. Now I'm going to reduce, cancel 1a from the numerator with the a from the denominator, all 3 b's in the numerator with 3 of the b's from the denominator. What I'm left with in my answer are 3 a's in the numerator, 2 b's in the denominator. So my answer should be 8a cubed over 7b squared. If I want to check, I need to pick a number for a and a number for b, plug them into the original problem, and plug them into my answer. And I don't like picking one, so I'm going to pick 2 for a. So for checking, I'm going to let a equal to 2 and b equal to 3 and go to the original problem and go 24 times 2 to the 4th times 3 cubed over 21 times 2 times 3 to the 5th. See what that equals to. And I'll do the same thing for my answer. I'll come to my answer and I'll go 8 times 2 cubed over 7 times 3 squared, plugging in 2 for a and 3 for b. If both of these computations reduce to the same fraction or the same number, then my answer, I feel good about it. If they come out to different numbers, then I think I made a mistake. So checking, I'm going 24 parentheses 2 to the 4th parentheses 3 cubed over 21 times 2 times 3 to the 5th. And I get 64 over 63 when I plug in 2 for a and 3 for b into the original problem. If I don't get 64 over 3 when I come here, and I'm really kind of 64 over 63, I'm worried that I made a mistake, but I don't think I did. So let me do this one now. So fraction 8 times 2 cubed over 7 times 3 squared, and I get the same 64 over 63, so I feel good about my answer because I got the same fraction by plugging the same numbers into the original problem as I did my answer, and that's the best I can do for checking this style of problem. Part B, I can't cancel the 16 and the 64. I can't cancel the x's because of the big subtraction sign in the numerator and the denominator. In part B, I have to factor and cancel. The numerator, there's a common factor of a 2 that I'm going to factor out. When I factor out that 2, I'm going to be left with an x minus 8. The denominator factors, it's a difference of squares. I get 2 essentially identical parentheses, one with a plus sign, one with a minus sign. And it factors into x plus 8 times x minus 8. Once I factor, I can see the x minus 8's cancel. I should know that a 2 and an x plus 8 can't cancel. You can't cancel an x that has a plus with it with anything other than identical copy, and x plus 8 can only cancel with an x plus 8. Again, I want to check. I'm going to plug in 2 for x for my checking. I'm going to go to the original problem and go 2 times 2 minus 16 over 2 squared minus 64. Don't really need that parentheses, but it's okay. And I'm going to go to my answer and go 2 over 2 plus 8. So I'm going to take the x's in the original problem, take the x's in my answer, change them to 2, reduce both those fractions. If they equal the same, then my answer is good. If they don't equal the same, then I've made a mistake. So there's the computation for plugging in 2 to the original problem for x, and I get 1/5 when I do that. Do the same thing for the answer. Go 2 over 2 plus 8. Also get 1/5. Again, because these fractions are the same number, I feel good about my work. And that answer, 2 over x plus 8, is the best I can do. Another factor and cancel. Part C is equivalent to A and B, and that's asking me to reduce a fraction. I don't know why I just put the x minus 3 in a parentheses in the numerator, but it's not wrong to have it there. I need to factor the denominator. The signs are going to be minus and minus, so I can get a minus 1 and a minus 6. or minus 2 and a minus 3. And the minus 2 and minus 3 are going to be the pair, because minus 2 times minus 3 multiplies to be positive 6. Minus 2 plus minus 3 adds to be minus 5. So after the x's, I'm going to get a minus 2 and a minus 3. I'm going to cancel the x minus 3's. If I just wrote x minus 2 for an answer, my answer would be wrong. It's okay if you cancel the entire denominator to make your answer not be a fraction. But if you cancel the entire numerator and there's something left in the denominator, you have to leave a 1 behind in the numerator. So this should be my answer. If I just wrote x minus 2, the checking part's going to blow up on me. I can't plug 2 in for x or 3 in for x for my checking because that would cause a 0 in my denominator. I'm going to check with x equal to 4. If I tried to check with x equal to 2 and did it on my calculator, I'm going to get that error message. But checking with x equal 4, going to the original problem, changing the x to 4, don't really need the parentheses with the square, but it's okay to have them. I'll go to the original problem and plug 4 in for x. I'll go into my answer and plug 4 in for x. And if I get the same number, I feel good about my work. So fraction 4 minus 3 over 4 squared minus 5 times 4 plus 6. I get 1/2 when I plug in x equal 4 into the original problem. When I plug x equal to 4 into my answer, I get 1 over 4 minus 2, which is also 1/2. So because I got the same result, plugging 4 into the original problem as my answer, I feel good. If your answer wasn't a fraction and you wrote just x minus 2, if you checked it and you plugged 4 in, you'd get 2 and not 1/2. And you need to get 1/2 for it to be correct. So if you made the mistake of writing an answer that's not a fraction and you checked it, your checkings wouldn't match. You'd get 1/2 when you put 4 into the original problem. You'd get 2 when you plug 4 into the answer. Or whatever number you pick. If you checked with x equal to 5, you'd get a different result putting 5 into the original problem as to the answer. 3's a mess. 3 is a division problem, so I need to invert and multiply. And I like both pieces to be a fraction. So I'm going to do 2 things on my first step for number 3, part A. I'm going to make a fraction out of the x squared plus 5x plus 6, and I'm going to change the division to multiplication. This is a factoring and canceling problem. I need to factor the x squared plus 5x plus 6 and the 3x squared plus 4x minus 4. The 1 doesn't factor and the 3x minus 2 doesn't factor. This is easy factoring. X squared plus 5x plus 6, there's not a number in front of the x squared, so I'm not worried about bottoms up factoring. I don't have to worry about signs because there's nothing but plus signs. My lasts are going to multiply to 6 and add to 5. They're going to be 2 and 3. To do this factoring, it's bottoms up. And so I'm going to do this right off to the side here. I'm going to bottoms up factor 3x squared plus 4x minus 4. First step is to multiply. I'm going to multiply the 3 and the 4, and I get x squared plus 4x minus 12. So it's multiply, then factor. That factors into x plus 6 times x minus 2. Then divide, reduce, and bottoms up. I started off multiplying the last number by 3. I'm going to end up dividing the last number by 3. The 6 over 3 reduces to 2. The next fraction doesn't reduce, so I bottoms up to 3x minus 2. So I'm going to get x plus 2 times 3x minus 2 when I rewrite the denominator 3x squared plus 4x minus 4. Now I'm going to do a lot of canceling. I can cancel between fractions or within the same fraction as long as I'm canceling a numerator with a denominator. So the 3x minus 2's, even though they're not in opposite fractions because one's up in a numerator and the other's in a denominator, I can cancel. Similarly, the x plus 2's can cancel. In the last problem, The only thing that didn't cancel was in a denominator, and I needed to write my answer as a fraction. This problem, the only thing I didn't cancel is in a numerator, and my denominators are all gone. My answer doesn't have to be a fraction, and I don't really need the parentheses around the x plus 3 anymore. I'm going to check. I think I can plug 2 in, because if I plug 2 in for x, then it doesn't make any of the parentheses 0. So I'm going to go to the original problem in my answer and plug 2 in for x for my checking. So for checking, I'm going to go 2 squared plus 5 times 2 plus 6 divided by 3 times 2 squared plus 4 times 2 minus 4 over 3 times 4 minus 2. And I'm also going to do 4 plus 3. That one I'm not going to use my calculator for. Plugging in, I'm going to plug in 2. I'm going to go 2 plus 3, because I decided I'm plugging 2 in. And I'll get 5. So when I do this work here, I better get 5. If I don't get 5, I've made a mistake. I'm going to enter it just like it looks. So parentheses 2 squared plus 5 parentheses 2 plus 6 parentheses divided by fraction 3 times 2 squared plus 4 times 2 minus 4 over 3 times 4 minus 2. Hit enter, and I best see the number 5. Oh, I see 25 over 2. That's really not a pleasant thing to see. I did the calculator work really fast. I'm going to redo the calculator work to see if I've made a mistake. So I don't think I have an error. I think I blew my calculator. So I'm going to try this again. Oh, I did. Right here is where I blew it up. This should be a 2 right here, because I'm plugging in 2 for x. I don't know why I made that a 4. I did it down here too. It just got a little spacey. So my checking messed up, because I said I was going to change the x's to 2, and I changed most of the x's to 2, but not that one. Now I'm going to recheck. So I'm going to go 2 squared plus 5 times 2 plus 6 divided by fraction 3 times 2 squared plus 4 times 2 minus 4 over, is where I messed up, 3 times 2 minus 2. Oh, beautiful, and I get the 5 that I hope to get. So I believe my answer is correct. Part B is another factoring and canceling, and it has one tricky factoring. So I'm going to go off on the bottom here and factor each. So I'm going to need to factor all 4 pieces. The first piece I'm going to factor is y squared minus 3y plus 2. I know that I don't need bottoms up factoring for that, and I know my signs have to be minus and minus, and really my only choices are minus 1 and minus 2, because minus 1 times minus 2 multiplies to positive 2, minus 1 plus minus 2 is minus 3. So that numerator, the top left numerator, factors into y minus 1 times y minus 2. The next thing I want to factor is the hard one. The 3 times y squared minus 12. That's a 2-step factoring. To factor that, the first thing I need to do is pull out a common factor of a 3. And when I pull out a common factor of a 3, I'll be left with a y squared minus 4. That 3 is going to stay in front of the factoring, but the y squared minus 4 is going to factor more. And that y squared minus 4 factors into y plus 2 and y minus 2. So in the denominator, in the first fraction, you get 3 times y plus 2 times y minus 2. These other 2 factorings are nothing but plus signs. They're easy for me, so I'm just going to do them right in line here. I'm factoring y squared plus 6y plus 8. I know I don't need bottoms up because there's not a number in front of the y squared. There's no minus sign, so I get a couple plus signs. My lasts have to multiply to 8 and add to 6. That'll be 2 and 4. And this denominator, y squared plus 5y plus 4, I know I'm getting a couple of y pluses. my lasts have to multiply to 4 and add to 5, and that's going to be 1 and 4. Now I can cancel within the same fraction or between fractions as long as I have the same binomials. So the things that will cancel, this y plus 2 and that y plus 2, this y minus 2 with that y minus 2, this y plus 4 and that y plus 4. A y minus 1 and a y plus 1, as much as you might like to cancel them, they don't cancel. So what I have left in the numerator is a y minus 1. What I haven't canceled in the denominator is a 3 times y plus 1. This is probably the best answer. But if you take the time to multiply out that denominator, there's nothing wrong with that. And so if you wrote y minus 1 over 3y plus 3, that's completely okay. It's also correct. And I'd give you full credit for both answers. I can't plug 2 in for y in my checking because I'd get a 0 there, which is not good. But 3 doesn't look to be a bad number, so I'm going to check by plugging a bunch of 3's in. Nice that I pick a positive number because I don't need the parentheses. So I'm going to check by taking y equal to 3 and plug it into my original problem. I'm going to go 3 squared minus 3 times 3 plus 2 over 3 times 3 squared minus 12 times 3 squared plus 6 times 3 plus 8 over 3 squared plus 5 times 3 plus 4. And then I'll check here as well. I'm going to go 3 minus 1 over 3 times 3 plus 1. So this checking's the horrible one, but it's not that horrible because I can just mindlessly press buttons. So I'm going to try to mindlessly press these buttons now. So start off here. I'm going to go fraction 3 squared minus 3 times 3. Oh, that's not good. Fraction 3 squared minus 3 times 3 plus 2 over 3 times 3 squared minus 12, arrow out of that, times fraction 3 squared plus 6 times 3 plus 8 over 3 squared plus 5 times 3 plus 4. It was a lot of typing. Hopefully I didn't mess anything up. I got 1 over 6. Now I'm going to go to my answer with the y changed to 3 and do the same. So I'm going to go 3 minus 1 over 3 times 3 plus 1. And I get 1/6 again. So I'm comfortable with my answer. And like I said, that version of the answer I think is probably better, but that version of the answer isn't really significantly worse or different. So I take both. Dang. C, 4 factorings again. 2 bottoms up factoring. And the checking's going to be a disaster, but I'll deal with it. First thing I want to do is change the problem into a multiplication problem. I could have factored 2 on this first step, but I like to kind of just do one step at a time. So I'm going to take the division sign, flip it to multiplication, and to flip the division sign to a multiplication, I need to flip a fraction. Now I'm going to do my factorings. I have 2 easy factorings, 2 hard factorings. The numerator b squared plus 4b plus 5b plus 4 factors into b plus 1 times b plus 4. Now to do this factoring, I'm going to do it off to the side. I'm going to factor using bottoms up factoring. This 3b squared plus 8b plus 5. I multiply and get b squared plus 8b plus 15. Then I factor. That factors into b plus 3 times b plus 5. I started off multiplying the last number by 3. I'm going to divide the last number by 3. Reduce the first fraction. Bottoms up the second fraction. And this 3b squared plus 8b plus 5 factors into b plus 1 times 3b plus 5. Next mess I'm going to factor is 3b squared plus 2b minus 5. Bottoms up again. Multiply the 3 and the 5 and get b squared plus 2b minus 15. Factor this into b plus 5 times b minus 3, because I had to multiply to 15, subtract to 2. Started off multiplying by 3. I'm going to divide by 3. And I get a 3b plus 5 times b minus 1. So for that 3b squared plus 2b minus 5, I'm going to put 3b plus 5 times b minus 1. And in the denominator, that's a b plus 4, b minus 4. Now I'm going to start canceling. Same fraction are between fractions. Top to bottom, b plus 1's cancel. 3b plus 5's cancel. b plus 4's cancel. I'm left with my answer. I don't need the parentheses anymore because there's only one factor left in the numerator and one in the denominator. I'd like to plug 2 in. If I don't have any b minus 2 factors, I can plug 2 in. So my checking, I'm going to plug 2 in. I'm going to check right up here. I'm going to go 2 squared plus 5 times 2 plus 4 over 3 times 2 squared plus 8 times 2 plus 5 divided by 2 squared minus 16 over 3 times 2 squared plus 2 times 2 minus 5. And for my answer, it's going to be easy to check. I'm just going to go 2 minus 1 over 2 minus 4. So start with the messy checking. So for the messy checking, fraction 2 squared plus 5 times 2 plus 4 over 3 times 2 squared plus 8 times 2 plus 5. Arrow out of it. Divide by fraction 2 squared minus 16 over 3 times 2 squared plus 2 times 2 minus 5. Enter. I get negative 1/2 when I plug 2 into the original problem. Now I'm going to do the computation in my answer. I'm going to go 2 minus 1 over 2 minus 4. I also get negative 1/2. So again, I'm feeling good about my answer because I did the check that I can do and the numbers matched up. I sense that the test isn't going to be near as long as the review because it's already taken me a long time and I could never make a test that has this many parts to it. 4a, there's a little wiggle room in terms of how you do the problem. If you just multiplied the left fraction by 5 over 5 without factoring the right denominator, that's okay. I'm going to factor the right denominator. So if your answer, I'll write down what answers I would accept. And so if your work's a little bit different, that's okay. So for adding or subtracting, you need equal denominators. Both denominator has an x minus 4. The right one has a 5. I have to multiply by 5 over 5 to make each denominator look the same. And when you're adding or subtracting, we don't have equal signs. We need the denominator to be the same. We multiply numerator and the denominator by the same thing. Multiplying by 5 over 5, I get 25 over 5 times x minus 4 plus 3 over 5 times x minus 4. Now that I have the two fractions written with the same denominator, I can add the numerators together and get to my answer. My answer is going to be 28 over 5 times x minus 4. I'm going to check by plugging in 2. It would be okay if your answer was 28 in the numerator and 5x minus 20 in the denominator. So if you didn't factor this And this line had a 5x minus 20 for both the denominators. That's completely okay. I'm going to check by plugging in 2. I'm going to go 5 over 2 minus 4 plus 3 over 5 times 2 minus 20. And I'm going to plug in 2 here. I'm going to go 28 over 5 times 2 minus 4. And the only way my answer is correct is if those numbers match up. So first computation, fraction, 5 over 2 minus 4 plus fraction 3 over 5 times 2 minus 20. I get negative 14 over 5. Now I'm going to come down and do this one. Do fraction 28 over 5 times 2 minus 4. When I do that computation, I also get negative 14 over 5, which makes my answer correct. So again, if you multiplied out the denominator or you didn't, both those answers okay. 28 is the only correct numerator. You have some wiggle room in your denominator for your answer. Part B is the friendly part here because the denominators are already the same. Because the denominators are already the same, I don't need to modify either of the fractions. I could immediately make the two fractions into one fraction by writing their numerators next to each other. Now I'm going to simplify the numerators. I'm going to take the 2x and the x, which is really 2x and 1x, and add those together. And the plus 3 and minus 18, I'm going to combine those or subtract those. So in the numerator, 2x plus 1x is going to be 3x. 3 minus 18 is negative 15. This is a correct answer, but not the best correct answer. The numerator is factorable. If I factor out a 3 from the numerator, I'll be left with an x minus 5. And the x minus 5s will cancel. I've canceled the entire denominator, so my answer doesn't need to be a fraction. My answer is just going to be what's left in the numerator, which is just the lonely number 3. When I check, I'm going to plug in 2 for x into the original problem. There's no place to plug in 2 for the answer, which means when I plug in 2 for x, I better get 3. So I'm going to do my checking. I'm going to go 2 times 2 plus 3 over 2 minus 5 plus 2 minus 18 over 2 minus 5, and hope like heck I get 3. That's the only way my answer could be correct. So fraction 2 times 2 plus 3 over 2 minus 5 plus fraction 2 minus 18 over 2 minus 5, and I get 3, and that's what I needed to get. There's no place to plug the 2 into the answer, but I already have the matching that I need to have. Part C is the worst part because it's a subtraction, which is a little bit harder than addition, and there's some factoring that I need to do. In part C, the first thing I'm going to do is factor the m squared minus 9. I'm going to factor it into m plus 3 times m minus 3. So both denominators need to have both an m plus 3 and an m minus 3. The second denominator has an m minus 3. If I just gave it an m plus 3, then both denominators are going to have the same components. So I'm going to multiply the second fraction by m plus 3 over m plus 3. I'm going to leave the first fraction temporarily alone, and I'm going to wait on messing with the minus sign for a second here. First, I'm going to clear that numerator multiplication. I'll go 4 times m and 4 times 3. And I'm going to write the denominator in the same order. Those parentheses are interchangeable, so I'll shuffle them around. Now I'm going to make the two fractions into one, and I'm going to worry about this minus sign, and I'm going to flip the sign, or change the sign. So when I make the two fractions into one, the minus sign's going to attach to the 4m, and it's going to flip the sign in front of the 12. Now I'm going to simplify the numerator. I'm going to go 5m minus 4m and plus 3 minus 12. 5n minus 4m is 1m. 3 minus 12 is minus 9. That doesn't factor, and I can't do any canceling. You can't cancel an m with a minus with something that isn't identical. An m minus 9 will only cancel with another m minus 9. So I believe this is my answer. Again, I'm going to plug 2 in just because it's an easy number for me to do. So I'm going to check. I'm going to let m equal to 2. I'm going to go 5 times 2 plus 3 over 2 squared minus 9 minus 4 over 2 minus 3. And in my answer, I'm going to go 2 minus 9 over 2 plus 3 times 2 minus 3. So I'll do both those computations. Hopefully I get the same answers. First computation, original problem, 5 times 2 plus 3 over 2 squared minus 9 minus fraction 4 over 2 minus 3. I get 7/5, which means I better get another 7/5 down here. When I work down here, fraction 2 minus 9 over parentheses 2 plus 3 times 2 minus 3. If I don't get 7/5, I've messed up. And I do. Beautiful. So this answer is beautiful. You could FOIL out the denominator, but we normally don't. One more. Two more. Way too many adding and subtracting problems for my liking. For this problem, I need to, because there's no factoring, I'm going to expand the b's in the right denominator. The 9 and the 4 need to be changed into the same number. I could change those both into a 36. So if I multiplied the first fraction by 4 over 4 and the second fraction by 9 over 9, what that would do for me is get me started, but it wouldn't take me the whole way, because doing that would give me 28 over 36b minus 27 over 36bb, and those two fractions can't be subtracted because they don't have exactly the same denominators. I should have, on the first step, gave myself a b up here. I should have multiplied this by 4b over 4b, because if I did that, I could have the first fraction as 28b over 36 times 2b's, which you can write as b squared. And the second fraction could be 27 over 36b squared. Now, because I have the denominators the same, I can write the two fractions together as one fraction. You can't get a 1 in the numerator. You can't subtract 28b minus 27. The only way I can get a 1 is if the b wasn't there or if the 27 had a b. So the numerator doesn't simplify. You can't combine those terms. And you can't subtract something with a subtraction with something that doesn't have any subtraction. So this is not going to cancel at all. This is going to be my answer. And I'm going to check. I'm going to let b equal to 2. I'm going to go 7 over 9 times 2 minus 3 over 4 times 2 squared. And I'm also going to go 28 times 2 minus 27 over 36 times 2 squared. The answer almost looks more complex than the original problem, but it's the correct answer because it's only one fraction as opposed to 2. So checking the original problem, fraction 7 over 9 times 2 minus fraction 3 over 4 times 2 squared, I get 29 over 144. Now I'm going to do the same for my answer. Fraction 28 parentheses 2 minus 27 over 36 times 2 squared. And I get 29 over 144 again. So perfection. So there really isn't a reason for any of the first, really for none of the problems on the test, there isn't a reason to write down a wrong answer, because it's not that hard to check. It takes me seconds to check these problems, and That's saving me from any mistakes that I might make. Ugh. Not excited about part E. Part E, I need to factor each denominator. So that first denominator is a mess. I'm going to factor 3x squared plus 2x minus 1 using bottoms up factoring off to the side. So I'm going to multiply the 3 and the minus 1 and get x squared plus 2x minus 3. That's the multiply. And I'm going to factor that. It factors into x plus 3 times x minus 1. That's the factor part. Then divide, reduce, and bottoms up. Started off multiplying the last number by 3. I end up dividing the last number by 3. I reduce the first fraction to x plus 1. Bottoms up the second fraction to get 3x minus 1. So I'm going to rewrite the first fraction as 6x over x plus 1 times 3x minus 1. Second fraction is easy factoring. It's just a square with a minus. I get two essentially identical parentheses, one with a plus, one with a minus. It factors into x plus 1 times x minus 1. Now I need to make the fractions have the same components in the denominator. The first fraction needs to be given the x minus 1 that the second fraction has. The second fraction needs to be given the 3x minus 1 that's in the denominator of the first fraction. So now I have each fraction with the same denominator. I'm going to multiply out the numerators. I'm going to go 6x times x and 6x times minus 1. 6x times x is 6x squared. 6x times minus 1 is minus 6x. I can write the denominators in any order that I choose. I can shuffle these parentheses around. There isn't a right and a wrong way to shuffle these parentheses, but I might as well write both sides the same. Now I'm going to simplify the right numerator. 5 times 3x is 15x. 5 times minus 1 is minus 5. I've picked an order for my denominator, so I'm going to stick with that order. Now I'm going to make the two fractions into one by writing their numerators together. Fortunately, it's not a subtraction problem, so I don't have to worry about changing signs. Now I'm going to simplify the numerator. This minus 6x plus 15x gives me a plus 9x. So I'm going to write 6x squared plus 9x minus 5. I'm virtually certain that's prime. You should try to bottoms up factor that. But I can see that it's prime and I just want to save the time. So I believe this is my answer. If that happened to bottoms up factoring and you missed it, I'd take a point off, so it's not a crucial deal. If you miss it, miss it. But check by plugging 2 in. So I'm going to check. I'm going to go 6 times 2 over 3 times 2 squared plus 2 times 2 minus 1 plus 5 over 2 squared minus 1. And I'll come down here and go 6 times 2 squared plus 9 times 2 minus 5 over 2 plus 1 times 2 minus 1 and 3 times 2 minus 1. So I'm going to do the double checking here and make sure that I pick that minus sign up. So checking 2 into the original problem. Fraction 6 times 2 over 3 times 2 squared plus 2 times 2 minus 1 plus fraction 5 over 2 squared minus 1. Assuming I entered it correctly, my calculator tells me that this comes out to 37 over 15. I'll do the same with my answer now. Go to my answer, fraction 6 times 2 squared plus 9 times 2 minus 5 over 2 plus 1 2 plus 1 times 2 minus 1 times 3 times 2 minus 1. Enter. Oh, beautiful. 37 over 15. If these numbers didn't match, then I would have redone my calculator work, and if they still didn't match, then I would have started looking for an error, and a lot of times it's really hard for me to find my errors, and I just start the problems over. Hey, 5, finally we're getting to clear fractions differently. In 5, I'm not going to multiply by something over itself, I'm going to multiply by something over 1. In the denominators for problem 4, or problem 5a, if I multiply by 12, it will clear both the 4 and the 3. I'm going to multiply by 12 over 1, and I'm going to do it in pink. I'm going to go 12 over 1 times, and I'm doing it to the left of this fraction. You could do it to the left or the right of the fraction. It turns out that when the numerator is a binomial, doing that multiplication on the left is probably easier. So this is a lot different when you have the equal sign, what you're multiplying by. I'm multiplying by what I would turn the denominators into if I was adding or subtracting, but I'm doing it over 1. And because the 6 wasn't a fraction, I didn't toss the over 1 part. So now I'm ready to start clearing fractions. When the problem has an equal sign, you can clear fractions, and that's what I'm about to do. I'm going to cancel this 12 with this 4, and what I'm left with is 3 over 1 times x minus 4 over 1. I have a couple of over 1s, so I don't need the fractions anymore. What I'm really left with is just 3 times x minus 4. The parentheses tells me to multiply the 3 by the x and the 3 by the minus 4. Next piece, I bring my plus sign down, cancel the 3 with the 12. 12 turns into a 4, 3 turns into a 1. What I'm left with is x over 1 times 4 over 1. I don't need the over 1 parts. What I really have is just x times 4. And I'm going to write that as 4x. To the right of the equal sign, I didn't put the over 1 because I didn't need it. I'm just multiplying 6 times 12. So I need to solve this. There's no factoring because there's no square. I'm going to add the 3x and the 4x and get 7x. I'm going to leave the minus 12. Now I'm going to add 12 and divide by 7. When I add 12 to both sides, the 12 cancels on the left side. I'm left with 7x. On the right side, I get 84. Now I'm going to divide by 7. Divide by 7. Be safe and do this on my calculator. 84 over 7 is 12. I think the answer is x equal to 12. And on these problems, the answer is what I have to check. So for my checking, I have to plug in 12 for x to there. So I'm going to go 12 minus 4 over 4 plus 12 over 3 equals to 6. And see if that actually comes out to be a true statement. So left-hand side is the side I need to work on. So I'm going to go 12 minus 4 over 4 plus fraction 12 over 3. If I get 6 when I hit enter, then my answer is right. If I get something other than 6, my answer is wrong. I have to find my error. And I get 6, so my answer is correct, and I am done with that part of number 5. 5b, I need to multiply again to clear the fractions. Multiplying by x would clear that. Multiplying by x minus 1 would clear that. Multiplying by 4 will clear that. I need to multiply by 4x and x minus 1. And I can do that all to the right because none of the numerators have binomials in them. So I'm going to multiply by 4 times x minus 1 over 1. So that I'm going to clear every fraction. And when I have the equal signs, I multiply by something over 1 rather than something over itself. In the problems where I was just adding and subtracting and they didn't have equal signs, I multiplied by the same on the numerator and the denominator. But when you have equal signs, you're multiplying over 1. Now I'm going to go into canceling mode. First canceling, the x's cancel. I'm left with 6 over 1 times 4 times x minus 1 over 1. Don't need the over 1 parts, that's gone. What I have is 6 times 4 times x minus 1. And I'll just multiply that left to right. I'm going to multiply the 6 times 4 and get 24. And then I'm going to clear the parentheses. I'll go 24 times x and 24 times minus 1. This gives me 24x minus 24. Bring down my minus signs. Next piece, cancel x minus 1s. I'm left with 9 over 1 times 4x over 1. Don't need the over 1 part, so I'm really just left with 9 times 4x. 9 times 4x is just 36x. Right of the equal sign, cancel the 4's. I'm left with 1 over 1 times x minus 1 over 1. Don't need the over 1s, don't really even need that part at all. All I really need is this x times x minus 1. Because the 1 over 1 just goes away, it's multiplying by 1, and that over 1 you don't need either. Clear the parentheses, x times x is x squared, x times minus 1 is minus 1x. So I've cleared my parentheses. I have a square, which means I'm going to solve by factoring, which means I need to get a 0. But before I go about getting my 0, I'm going to simplify the left-hand side by combining 24x minus 36x and getting minus 12x. Now I'm ready to get my 0. I'm going to add 12x and add 24 to both sides. On the left side, when I add 12x and add 24, I'm going to get the 0 that I'm searching for. On the right side, the negative 1x and positive 12x gives me a positive 11x. And the 24 just stays 24. I have to factor that. It's easy factoring. It's no bottoms up because there's not a number in front of the x squared. My lasts have to multiply to 24 and add to 11. That will be 3 and 8. Now that I have it factored and set equal to 0, I split the factors up and set each one separately equal to 0. For the x plus 8 factor, I minus 8 from both sides and get x equal to minus 8. For the x plus 3 factor, I minus 3 from both sides and get x equal to minus 3. What I think the answers are x equal minus 8 and minus 3. I need to check both of them separately. I'll do it up top. So the first thing I'm going to do is I'm going to check x equal to minus 3. I'll go 6 over minus 3 minus 9 over minus 3 minus 1 and see if that equals to 1/4. And then I'll check the other answer, negative 8, and go 6 over negative 8 minus 9 over negative 8 minus 1 and see if that equals to 1/4. So for both checkings, I really just have to check the left side because the right side's already a single fraction. So for the negative 3, this has to come out to 1/4. So I'm going to go 6 over negative 3 minus fraction 9 over negative 3 minus 1. And when I do that, beautiful, I get 1/4. So for this one, you get 1/4 equals to 1/4. So that is checked. So I know negative 3 is in fact a solution. I'm going to come over here and do the same. 6 over negative 8 minus fraction 9 over negative 8 minus 1. And I hope I get another 1/4, and I do. So this gives me 1/4 equals to 1/4. So the answer of negative 8 and negative 3, they're the correct answers, and I've checked them. C looks like a problem that's going to have an extraneous solution. There's no solutions on the test that are extraneous, meaning you could do perfect algebra and you get a solution that doesn't check. So if you wound up skipping part C, it probably wouldn't be dangerous. But I'll do it anyways. So I'm going to factor the denominator that needs factoring. And that's the denominator to the right of the equal sign. And it's going to factor I know I need a couple of minuses. The signs have to be minus and minus. My choices would be minus 1 times minus 8 or minus 2 times minus 4, because both of those multiply to positive 8. I need the minus 2 and the minus 4. Now I'm going to multiply to clear my fractions by something over 1. For the first one, I'm going to multiply by x minus 2 times x minus 4 over 1. And once I've committed to that, I have to do it to everything. Second fraction, I also multiply by x minus 2 times x minus 4 over 1. And the last piece, I also multiply by x minus 2 times x minus 4 over 1. Cancel. First piece, I get x over 1 times x minus 4 over 1. Don't need the over 1s. Do need the x times x minus 4 part. Multiply x times x and x times minus 4. I get x squared minus 4x. Second piece, I cancel the x minus 4s. I get 1 over 1 times x minus 2 over 1. Don't need the over 1s. Don't really even need the 1s. Really what I have is 1 times x minus 2, which is just 1x minus 2, or x minus 2. You don't have to have the 1, but it's okay to have it. Might make it easier to have that 1. Right of the equal sign, you get 2 over 1 times 1 over 1, and that's just 2 times 1, which is 2. So now I have the problem without fractions. I'm going to combine these terms, a minus 4 and a positive 1x, and get a negative 3x. So I get x squared minus 3x minus 2 equals to 2. I'm going to minus 2 from both sides and get x squared minus 3x minus 4 equals to 0. Oh, this actually works just, maybe it doesn't. Now I factor this, and this is where it messes me up. I get x plus 1 times x minus 4 equal to 0. It factors because one of the factors is the same as one of the denominators. The number that comes from that is not going to be a solution. Running out of room, I'll come over here, and I'm going to go x plus 1 equal to 0, x minus 4 equal to 0. For the x plus 1, you minus 1 from both sides and get x equal to minus 1. For the x minus 4, I add both sides to 4, and you get x equal to 4. I need to check both negative 1 and 4. I'm going to do it on a different sheet of paper just because I'm out of room. So first thing I'm going to do is check x equal to negative 1. I have to check both sides here, unfortunately. I'm going to go negative 1 over negative 1 minus 2 plus 1 over negative 1 minus 4 equals to 2 over negative 1 squared minus 6 times negative 1 plus 8. Check each side separately. Left side, fraction negative 1 over negative 1 minus 2 plus fraction 1 over negative 1 minus 4, and I get 2/15. For this answer to be okay, I need to get another 2/15. So I'm going to go fraction 2 over negative 1 squared minus 6 times negative 1 plus 8, and I get the same 2/15. So negative 1 is definitely a solution because when I plug it into the original problem, I get a true statement. When I go to check the x equal to 4, something bad's going to happen. I'm going to get a math error on my calculator because it's going to make one of the denominators 0. And that's the kind of solution that isn't a solution. So when I go to write my answer, I need to say that 4 is not a solution, that it doesn't check. Again, this won't come up on the test. You won't be able to do perfect algebra and generate a solution that doesn't check on the test. I'll show you what's going to happen though. When I do this left-hand side, this fraction is going to be 1 over 0, which is undefined, and it's going to make my calculator give me that error message. So I'm going to go 4 over 4 minus 2 on the left side plus 1 over 4 minus 4. It gives me the big error message. When I get that error message, that means 4 is not a solution because it doesn't check. For it to check, I need to get a balance on each side of the equal sign. This gives me an undefined, and that side also gives me undefined, but it's enough to stop once you get an undefined. And again, that's not going to make it onto the test. If I was writing an answer for part C, I would do this. I would say x equal -1 is the only solution because it checks. So I'll say x equal -1 is a solution, but x equal 4 is not a solution. And that would be a nice way to write this answer. That would tell me you did the algebra, that the algebra gave you -1 and +4, that -1 checked and +4 didn't check. Again, it won't happen on the test that we're going to generate solutions that don't check, so this is not going to, it's something I want you to see again because it comes up in Math 151, but I know I'm not going to test on it, so it's not a deal breaker. Ugh, boy, it's a long review. I need to multiply by 2x's to get rid of that, 1x to get rid of that. Let me rewrite this problem as 1 minus 2 over x equals 8 over 2x's. And what I'm going to multiply by are 2x's over 1. For the first one, I don't need to multiply by the fraction because it's not a fraction. But for my other fractions, I'm going to clear the fractions by multiplying by 2x's over 1. And now I'm going to work on simplifying this and clearing the fractions. So this piece right here, 1 times x, that just comes out to be x squared. There's no fractions that were necessary there. Next piece, cancel the x's. I get minus 2 over 1 times x over 1. That's just going to be minus 2x. To the right of the equal sign, the x's cancel. I get 8 over 1 times 1 over 1, and that's just 8. I don't need the denominators because there's 1s, and 8 times 1 is 8. I need to get the problem solved by factoring because of the x squared, which means I need to have the problem set equal to 0. I do that by minusing 8 from both sides. And now I'm going to factor this. This factors into x plus 2 times x minus 4. Once I have the problem set equal to 0 and factored, I split the factors up, set each one separately equal to 0. The x plus 2 factor, I minus 2 from both sides, and get an answer of x equal to minus 2. The x minus 4 factor, I add 4 to both sides and get an answer of 4. I'm going to check both of these because I can. For the -2, I'm going to go 1 minus 2 over -2 and see if that equals 8 over -2 squared. For the x equal to 4, I'm going to go 1 minus 2 over 4, see if that equals 8 over 4 squared. So I need to do each side separately. Left side, first checking, I'm doing 1 minus fraction 2 over -2. This gives me 2, which means that better also give me 2. That side I'm doing 8 over parentheses -2 squared, and I also get 2. So because I get 2 on each side when I plug -2 in, -2 is a solution. Go over here to check the 4. I'm going to go 1 minus fraction 2 over 4. I get 1/2 on the left side. For the right side, I go 8 over 4 squared, and I also get 1/2. So both numbers, when I put them in, give me true statements, 2 equal to 2, 1/2 equal to 1/2. So both -2 and 4 are solutions. Finally, a nice couple of friendly problems. The last two parts here I can solve by cross multiplying because they're one fraction equal to another fraction. So I'm going to cross multiply down and up. I'm going to get 2x times 3 equals to 5 times x plus 1, which gives me 6x equals 5x plus 5. There's no square, so I don't have to factor. I do need to get the x's on the same side, so I'm going to minus 5x from both sides. When I do that, on the left side, 6x minus 5x is 1x. The right side, I get 5. I think that's my answer. I should check. I'm going to put 5 in for the x's and see if 5 plus 1 over 2 times 5 equals 3/5. The right side's already reduced. I don't need to do that on my calculator. The left side, I'll use my calculator. I'm going to go 5 plus 1 over 2 times 5. And I get 3/5 equal to 3/5, so my answer is perfectly correct. Last cross multiplying problem, and then the word problems. So I'm going to cross multiply up and cross multiply down. I'm going to get 5 times x equals 3 times 2x minus 3. This gives me 5x equals 6x minus 9. I'm going to minus 6x from both sides, which is going to give me minus 1x equals to minus 9. I'll divide both sides by a minus 1 and get x equal to positive 9. I'm going to check it by going 5 over 2 times 9 minus 3 and see if that equals to 3 over 9. So left side, fraction 5 over 2 times 9 minus 3. Left side reduces to 1/3. Right side, 3 over 9. That also reduces to 1/3, so I know my answer is correct. And I unfortunately, or maybe fortunately, just have to go, so I'm going to finish up this review and do the word problems on a part 2. So you'll have to switch videos to see me do problems 6, 7, and 8, which are only 3 problems. I just don't have the time, I'm sorry. So that'll be a short little 20-minute video that you'll get.